Okay, so the future of energy, it's electrifying.
Literally.
Yeah, literally. And we see solar and wind, they're always grabbing headlines.
Right.
But, today we're going to do a deep dive based on the stuff we've been reading.
Absolutely.
And we're going to uncover some of these kind of hidden engines that are powering this whole energy transition. We're going to be talking about everything from biofuels, like hydrogen and ammonia. We'll touch upon the role of carbon capture. We'll look at natural gas, geothermal, the revolution that's going on in clean manufacturing.
Like steel and cement?
Yeah, steel and cement. And then, of course, this monumental task of, building out this global grid.
With nuclear, solar, and storage.
Yeah, with nuclear, solar, and storage. Basically, the mission here is for you, the listener, to gain a really solid understanding of all these key debates that are happening and the super cutting-edge advancements that are shaping our energy future.
Without getting lost in the weeds.
Yeah.
Exactly, without getting too bogged down in the technical weeds. So let's jump right in. We've been seeing a lot of buzz around these new biofuels that are being used for energy storage and transport.
Yes.
And hydrogen and ammonia seem to be the key players here. Who do you think has the edge in making this stuff scalable?
Well, I think what's really interesting is just how much near-term practicality we're seeing come up.
Okay.
And so while hydrogen has a lot of potential in the long term,
Right.
it has some limitations right now, mainly how we can actually store the stuff.
I see.
It takes a lot of compression, or you need it at really low temperatures,
Yeah.
which makes it kind of hard to move around. And so that's kind of where ammonia is getting the edge right now, because it's easier to transport on a large scale. It's more energy dense. And you can even use some of the infrastructure we already have.
Right.
Even though, we have to think about the emissions that come from producing it.
Yeah. Okay, that makes sense. But can either of these really take on fossil fuels?
Yeah. In these really, really tough industries, shipping and heavy industries.
Absolutely.
That just seems like a huge hurdle.
Yeah, if you connect it back to the bigger picture,
Mm-hmm.
the scale is just immense.
Right.
For both of these, we need major upgrades to infrastructure. We need more technological breakthroughs to make them actually cost-effective
And
and scalable.
Scalable, yeah.
For those industries. It's not just a simple swap.
Right.
You need to re-engineer the whole process.
Exactly. Okay, so carbon capture. Is this, a genuine climate solution?
Is it real?
Or is it just, are we just kicking the can down the road, or just giving more life to fossil fuels?
Prolonging.
Yeah.
Prolonging fossil fuels.
Some of the research we looked at presented it as both.
It's a bit of a double-edged sword.
Yeah, it's a very interesting debate. Where do you fall?
So I think the true value of carbon capture really hinges on these engineering breakthroughs. We need to make it energy efficient.
Yeah.
We need to make it affordable.
If it can be done at scale.
Yeah, and at scale.
Yeah.
And that's why there's all these debates about funding. Is it actually helping fossil fuels stay around longer?
Right.
Or is it helping us reduce emissions in these sectors that are hard to change?
Yeah.
Like cement production.
Mm.
To know its true impact, we need to see how projects are actually doing in the real world. Are they succeeding or failing?
That's a good point. Okay, so building on, the need for reliable energy,
Yes.
let's look at natural gas and geothermal.
The quiet players.
Yeah, they're often seen as these quieter players in the clean energy game. Geothermal always seemed so promising to me.
It's a consistent underground energy source.
It is. It's consistent. Why isn't it more mainstream?
Well, I think geothermal has a huge potential to be this baseload power source.
Meaning
It's super reliable 24/7. But historically, getting at it economically has been the challenge.
I see.
But there's all these advances happening in drilling that are making geothermal resources that used to be out of reach.
Wow.
Now they're becoming viable, and it could really change things up in certain regions.
Yeah, it's almost surprising we don't hear more about it.
Right.
Okay, so what about natural gas? Can we decarbonize it enough to make it a long-term partner to renewables, or is it just a bridge technology that's, kind of nearing its end?
Well, I think if we want to meet these really ambitious climate goals, decarbonizing natural gas enough is going to be a huge challenge.
I see.
There are technologies out there you can use carbon capture in gas plants,
Right.
but how well they work and how much they cost
Right.
are still the big questions. In the long run, I think we're moving towards replacing natural gas altogether.
Okay.
But it might still be useful in keeping the grid stable
Right.
while we're transitioning over to renewables.
That's a good point. Okay, so let's switch gears a little bit and talk about manufacturing.
Okay.
How we make things. We've seen companies like MOE Steel that are aiming for cleaner production methods.
Right.
Can these efforts to clean up steel and cement really make a difference globally?
Can they scale up?
Yeah, can they scale up?
Well, what I think is so cool is that people are finally recognizing
Yeah.
that we have to clean up heavy industries.
It's a big one.
It's a big one. And companies like MOE Steel are showing us that it's possible
Yeah.
to rethink how we do these fundamental processes.
Right.
And there's this thing called green hydrogen,
Okay.
which is hydrogen made from renewable energy.
I see.
But how much different sectors are adopting, it varies a lot.
Right.
And it's usually driven by, what kind of policies are in place.
Yeah. Okay.
So the big question to get is scalability. We need the technology to keep advancing.
Right.
And we need policies that encourage these changes.
Exactly. Okay, so finally, let's zoom out and look at the big picture.
The global grid.
The global grid. Can we power the whole world using just renewables?
Solar wind.
Solar wind?
Yeah.
Or is nuclear still a must-have?
It's a big question.
And the trillion-dollar question, of course.
Who pays for all of this?
Yeah, who pays for all of this?
Right.
This massive transformation.
Yeah, this is the trillion-dollar question.
It is.
Isn't it? The whole debate about whether we should go all renewable or include nuclear
Right.
often comes down to two things:
Okay.
energy security
Okay.
and land use.
I see. Yep.
If we want a system that runs 100% on renewables,
Right.
we need massive amounts of energy storage
Yeah.
and these really advanced, smart grid management systems.
Right.
Because solar and wind, they're not always there.
That's true.
They fluctuate. And that's what we call intermittency.
Interesting.
So nuclear, on the other hand, that offers consistent power
Right.
and it's low carbon,
Yeah.
but then you have to deal with the cost
Right.
and the waste. It's not an easy answer.
Right.
And to pay for this global overhaul,
Yeah.
we need huge amounts of investment from both public and private sectors.
Right.
And we need countries to work together. These new smart grid systems are going to be crucial in balancing out, the ups and downs of renewables with what people actually need.
It's just the scale of it is just mind-blowing.
Yeah, it's mind-boggling.
It really is. Okay, so we've covered a lot today. We've talked about biofuels,
Yeah.
carbon capture, these often overlooked energy sources,
Right.
the greening of heavy industry,
Yeah.
and this enormous challenge of the global grid.
And it's all connected.
And they are all connected. How so?
So like the limitations we have with energy storage affect how realistic a 100% renewable grid really is.
Okay.
And if we want to clean up manufacturing,
Right.
well, we need access to clean energy.
Right.
And for all of this to happen, we need massive investment and constant innovation.
Exactly. So considering all these different solutions and all these massive investments that are needed, what do you think is going to be the single biggest factor that determines how quickly and successfully we can electrify the world?
That's a tough one.
It's a tough one because there's so many pieces moving at once.
There are. Is it going to be how fast the technology advances?
Okay.
Is it going to be the impact of government policies and regulations?
Right.
Or maybe it's about changes in what consumers want
Yeah.
or how well countries can cooperate with each other.
Right.
It's probably going to be a mix of all these things.
Yeah.
But I think figuring out which ones have the most influence,
Yeah.
that's going to be really important
It is.
as we move through this energy transformation.
Food for thought.
Food for thought.
That's it for this deep dive. Thanks for listening.
Thanks for having me.
An electric car, partially powered by solar panels.
The solar panels are fully charged.
Everything's powered by the solar panel.